Heyo, this is Miss Morrison for number 15 from 10.3. I'm gonna show you how to do this equation of the tangent line at x equals 2. But first, let me whip through finding the derivative real quick. If you already did that part, just fast forward. Okay, so to find the derivative, we take the bottom, or 2 to the x, times the derivative of a top. Well, the derivative of a number, x, is just number. We learned that as a trick. Minus the top, 9x, parentheses, the derivative of the bottom. And the derivative of this bottom, since it's a number to the x, we look at our 10.2 tricks, where it says number to the x, the derivative is the same number to the x times ln of the number. So the derivative of this bottom is the same bottom times ln of this number, 2, all over the bottom squared. Whoops. Or 2 to the x squared. I'll rewrite it in a minute, my bad. Okay, and then we look at the left of the minus sign and right of the minus sign and see what's in common. And I see that from the left of the minus sign and the right of the minus sign, I see a GCF of 9 because there's a 9 on both sides. And I see a 2 to the x. So this is gonna be my GCF. I'm just gonna take it out to make it look a little prettier. Okay, so I'm gonna write 9, 2 to the x, and that 9 doesn't have to be in parentheses, but I put it in there. And then a big old parentheses or a big old bracket. I'm just gonna put a bracket. Brackets are the same as parentheses. They just look different so that you can really tell what's going on, that I took the 9 and the 2x out. Okay, so if I take the 9 and the 2x, 2 to the x, away from the left of this minus sign, it looks like I don't have anything, but technically there's still a 1 multiplying by all that stuff. So I'm gonna take that 1 and write it down. So I picked up the 2 to the x and the 9 and I took it out and put it in front. And then I have left over a 1 minus, and let's see what we have on the inside here. If I take away the 2 to the x and the 9, looks like all I have is an x and an ln2. All over the bottom squared, or 2 to the x squared. Okay, and then this is technically the derivative. We could clean it up a little bit more, but I think in your homework, this is part A. This is what you first type in. So this is the derivative, and let's remember that the derivative is the slope, as in the letter m. So the second part of the problem says, find the equation of the tangent line. Well, the equation of the tangent line is y equals mx plus b. But first, we have to figure out what the m is. Well, this big old derivative sucker tells us what our m is, but we just have to plug in whatever x they told us to. So that part's gonna be the tricky part because of our calculator. So first I'm gonna find m. And m is the same thing as this big old derivative formula with a 9, and a 2, and then now I'm gonna plug in my x value. My x value was at x equals 2. So I'm taking this 2 and putting it wherever the x's are. Yeah, okay. And then I'm just going to go super slow. Okay, we're not really gonna mess with this ln stuff. Instead, let's mess with what's at the front up here. So, first off, if you notice, I see a 2 squared on the top and the bottom. Well, those can cancel. And they can cancel because on the top here, this 2 squared has an exponent of a pretend 1 outside. And on the bottom here, we have an exponent of a 2 outside. So this means that there's 1 2 squared on top and there's 2 2 squareds on bottom. Well, that's just like saying there's x on top and x squared on bottom. You can cancel one of the x's from the top with one of them from the bottom, and then all you're left with is an x on the bottom. We're going to do that same theory here, that if there's 1 of something on top and 2 of something on bottom, we can cancel out the top entirely and change the bottom to an exponent of 1. So that's what we're going to do here. I see an exponent of 1 on top, exponent of 2 on bottom. So this whole 2 squared is going to cancel out with one of these 2 squareds on the bottom. So that means this exponent of 2 on the outside becomes a 1. Okay, let's rewrite it. I'm just going super slow and rewriting every little step. So we have 9, and then that 2 squared on the top is gone. Then we have bracket 1 minus 2 ln 2 bracket, and brackets are the same thing as parentheses. And then all over whatever this 2 squared is. And that's going to be 4. So let's go ahead and do that sucker. On the bottom, we're going to get 4. On the top, we're going to distribute. 9 times 1 is 9. 9 times negative 2 is minus 18. With a ln 2 on it. So 9 multiply 1, 9. 9 multiplied this junk is, you just multiply the 9 and the number in the front. So 9 multiply negative 2, and then we tack on the ln 2. So 9 multiply negative 2 is negative 18. Then we tack on the ln 2. And although this is disgusting, this is the m. We technically did it. Usually we have slopes that look like, I don't know, m equals 9. That's usually what we have. Or we might have m equals 3/4. Yeah, that's our usual slope. But here, ours is still a slope because just with that 9 and that 3/4, those are just numbers. Well, for us, our slope is just a bunch of numbers. Even this ln 2, because technically ln 2, you can type that in the calculator and get a number. So even though this seems awkward that it's my slope, it is my slope because there's no letters left, because this ln 2 actually represents a number. So this is my slope. Okay, so now we're going to go back to y equals mx plus b. And I have my m, huzzah. I have my x, it's from up here, x equals 2, huzzah. The b is what I have to find at the very end, but I don't know my y yet. So let's find my y value so that I can plug it into this y equals mx plus b. Well, to find the y value, you're going to use the OG equation, the very original, 9x over 2 to the x. And we're going to plug in whatever our x value is. So we're going to use this 9x over 2 to the x. And we're going to plug in whatever my x value is that they gave us. And they gave us 2. So 9 times 2 over 2 to the 2. And on the top, we get a big fat 18. On the bottom, we get a big fat 4. And I think you can reduce that by 2. So we get 9 over 2. And this is the letter Y. And you might be asking, well, why the heck didn't I reduce this 18 over 4 up here? Well, I couldn't because this 18 ln 2 is technically also with this 9. So the only way I could reduce here from this big old m equation is if the 9 was even and the 18 and the 4. Then I could reduce all 3 of those. But since this 9 cannot be reduced with the 4, this big old sucker could not be reduced. because of that darn minus sign that was right there. Okay, so now that I have my y, I have to plug it into y equals mx plus b so I can find the b. It's going to be kind of scary because this is frightening, but it's okay. Okay, so my third step is to find y equals mx plus b. And we just found my y value to be 9/2 equals, my m was that big dirty equation, 9 minus 18 ln, all that janky stuff. Okay, I think I'm going to write that in parentheses because it looks terrifying. It says 9 minus 18 ln 2 over 4. Okay, so I just plugged in my y, bam, my m, bam. What was my x? Oh, it was 2. Okay, so let me plug in my 2. Bam. And then plus sign b. Okay, now we have to figure out what b is. Well, first, let's clean up this dirtiness over here. If I want to think of this differently, let's say I had x over 4 times 2. Yeah. Okay, if I wanted to multiply these, I could go left to right and get 2x over, this has a pretend 1, so 4 times 1 is 4. And then that would reduce to x over 2, because you can divide those by 2. So that's the long way to do it, to multiply it all out. There's a shortcut. The shortcut is you can say, hey, diagonals, I can reduce you since you're multiplied. And I can say, okay, this 2 and 4, if I reduce it, it makes a 1 and a 2, because I can divide both of those by 2. And then 1 times x, the 1 eventually disappears and we just get x on top. And then on bottom, we just have that 2 from when I reduced. So we're going to use that same theory here, that I can reduce diagonally. So let's reduce diagonally. This big fat 2 on the outside cancels out with this 4 on the bottom. And I'll put a 2 right there. Because remember on this last example, 2 and 4, you could divide those by 2 and it makes 1 and 2. And then, now let's rewrite this. We have 9/2 equals 9 minus 18 ln 2 all over 2. And then I'm going to take away the parentheses because I was really only using the parentheses to separate this 2. But this 2 disappears when I canceled it. So I don't need my parentheses anymore. And then I have plus b. Okay. So now what we're going to do is we're going to get m, let me start over. Now what we're going to do is we're going to get this b by itself. So this looks crazy, but if I would have, let's say, 9 equals 18 plus b, wouldn't I just subtract over this 18, blah, bam. Yeah, we're going to do that same thing here, use that same theory, only we're going to pick up this whole thing and subtract it to the other side. Yeah. So we're going to subtract this whole thing. And since I'm subtracting more than just an 18, because this is a big guy, I'm going to use parentheses. So if I was just subtracting maybe this 9, I'd say minus 9. If I was subtracting this 18, I'd say minus 18. But since I'm subtracting this big boy, I got to put him in parentheses. And then I'm going to subtract it from the left also. And on this right side, it cancels. So all I have left is this purple 9 over 2, minus parentheses this green stuff, minus parentheses this green stuff. Then let's see, 9 over 2 minus the green stuff, equal sign, equal sign. All this junk went away, and then we have plus b, or b. So this is equal to our b value, only it's kind of not what your answer is going to say, because these have the same denominator, so we can technically do something here. What we can do here is we can subtract the 9 and subtract that negative 18. Well, remember when I subtract something, when I distribute into a parentheses, the signs change. So this 9 over 2 is the same, but then I'm gonna subtract 9, and then I'm gonna subtract a negative 18. Well, two negatives make a positive. And it's all over 2. Okay. Now, if we remember back to algebra, if you have the same denominators, you can go ahead and squish it all together. As in, if I have 3 over 2 minus 4 over 2, this is the same thing as 3 minus 4 on top over a 2. And that pops out 3 minus 4, negative 1 over 2. Yeah. So we're going to use that theory here, this middle chunk, that if you have the same denominators, you can just go ahead and squish up the tops on one big long line. So let's do it. I have the same denominator, 2. Now I'm going to squish up the tops in one big long line. Okay, what do you see happens? Those 9s go away. What? It should be like that every time. Okay, and we get 18 ln 2 over 2, and that's my b. And then the very last step is we can reduce this fraction. Not the 2 on the ln, those are connected, they can never be touched. So don't touch that ln 2. But this 18 and 2, I think you can divide those by 2, and you get 18 divided by 2, 9 ln 2, all over a pretend 1, but we don't need that. So that's our b. Goodness. Okay, our very last step is to put it all together back into y equals mx plus b. And if you're panicking, it's okay. This is not going to be on the test. I'll put a baby problem on there without all this ln. Okay, so now we're going to put y equals mx plus b. And our m was this big dirty guy over here, 9 minus 18 ln 2 over 4. Yep, okay. So we're going to have y equals 19 minus 18 ln 2 over, what was it? Four. My bad. 4. Okay. 9 minus 18. 9 minus 18 ln 2 over 4. So we just took care of the m. Then for the x, we just put a big fat X right next to it. In the homework, you just type it right next to it. And then plus sign. My b is what we just got, 9 ln 2. Okay, and then this is the equation of the tangent line. This had a lot of moving parts. We had to remember so much stuff from back in the day. And again, this one won't be on a test because it's way too long.